If you want to listen to music, you open a media player. If you want to play a rhythm game, you launch a gaming app. And if you want to produce a track, you boot up a digital audio workstation. In standard mobile development, these functions are strictly isolated into distinct environments. Attempting to run these heavy-duty processes simultaneously on a single mobile device quickly maxes out the processor and drains available memory. Because these applications live in separate silos, they cannot share data in real time. A rhythm game cannot read the dynamic output of a track currently playing in your media app. This isolated architecture limits what you can do with your local music library. It forces the device to treat audio strictly as background media, rather than actionable data. Aura Eternity bundles 110 visualizers, 82 games, live telemetry, and a suite of DJ tools into a single cross-platform application. This visualization shows the core architectural thesis. The audio track itself acts as a continuous, real-time data stream that drives the entire ecosystem. To organize an application of this scale, the system relies on React and TypeScript, which provide the strict modular component architecture required to keep everything stable. The primary engineering tension here is data pipelining. The system must route massive amounts of data from the audio buffer to multiple rendering and logic engines concurrently, without blocking the main thread or causing the hardware to reach thermal failure. Aura Eternity operates as a unified, OS-like entertainment environment governed entirely by an audio heartbeat. At the foundational ingestion layer, the application natively hosts and decodes high-fidelity, lossless FLAC and WAV files. The continuous audio wave is mathematically sliced in real time, extracting specific frequency and amplitude data. This creates the master audio heartbeat, the single source of truth for the application's state. The data is then formatted into structured packets, distributed to visual, logic, and production modules. Through this pipeline, the ingestion engine turns a static media file into a continuous, dynamic stream of queryable architectural data. Those newly created audio data packets are routed directly into the application's dual visualizer engines. First, they feed into legacy butter churn and milk drop algorithms, which use the data points to generate classic 2D fractal visuals. A parallel data flow branches to a bespoke 3JS pipeline, utilizing the mobile GPU for complex 3D environments. Custom shaders listen for frequency spikes, triggering instant physical reactions in 3D models. Simultaneously, the UI uses adaptive theming, pulling dynamic color palettes from this same data stream. By passing the audio state data directly to the GPU shaders, the rendering pipeline bypasses the main React thread. This ensures critical frame rates are maintained despite the visual complexity on screen. Beyond visuals, the interactive logic engines use this same data feed. Rhythm game components parse the incoming beat and frequency data to automatically generate dynamic scrolling highways and hit markers. External hardware inputs create secondary data feedback loops. For example, microphone-driven breath control adds real-time physical input for interactive Zen modes. The data flow map expands, routing concurrent pathways to the Stockfish AI chess engine to process background game logic. Simultaneously, a serverless peer-to-peer layer, Tristero, manages external multiplayer states for collectible card battles, seamlessly syncing local audio states to instantly update global leaderboards. React's strict component structure is vital here. It isolates these heavy interactive and networking calculations from the visual rendering pipeline, preventing the UI from stuttering. The application also includes a creator tools layer, featuring a DJ panel and a chop shop interface where users interact directly with the track. User inputs through this interface trigger real-time pitch shifting and resequencing directly on the active audio buffer. This schematic illustrates a live audio signal passing through interchangeable FX nodes, layering dynamic delay and reverb directly onto the active master track. Because all systems read from a single shared audio buffer, manipulating the track via the chop shop creates a cascading effect. Changing the source audio immediately alters all the downstream interactive visualizers and the real-time background game logic. By allowing real-time buffer manipulation, the application closes the loop between music consumption and live production. Running 3D shaders, AI logic, and live FX chains simultaneously on a mobile device carries risks of battery drain and thermal throttling. This logic tree visualizes intelligent idling within the FX chain. A programmatic trigger actively detects unused processing nodes, It severs their connection to the audio stream, forcing them to visibly dim and disconnect from the network, immediately conserving CPU cycles. Aggressive, intelligent resource management is why this massive React and TypeScript ecosystem remains viable on mobile hardware. To bridge the web stack codebase with the native mobile operating system, the architecture uses Capacitor as a critical translation layer. Capacitor provides the native hooks necessary to compile and export the manipulated, chopped, and screwed sessions directly as high-quality WAV files. These exported tracks appear in the device's native media scanner instantly, requiring 0 server round trips to process the file. This native integration completes the architecture, turning a web-based user interface into a localized distribution node for music producers. Over 80 games and 100 visualizers within Aura Eternity do not operate independently. They function as listeners, subscribed to a single master audio heartbeat. This scale is achieved by combining React's component modularity with Capacitor's native bridging capabilities. This unified architectural approach expands the utility and value of a user's localized digital music library, turning static files into the engine for an entire entertainment system. Aura Eternity demonstrates that modern development frameworks can integrate media consumption, digital creation, and interactive gaming within a single application.